What if you could get power on demand with absolutely no moving parts, zero emissions, and no noise at all? It sounds like something straight out of science fiction, doesn't it? Well, today we're going to dig into a US patent for a device that claims it can do exactly that. Okay, so let's just jump right into the big question. It's a real head scratcher. I mean, everything we know about generating electricity involves motion, right? You've got spinning turbines, moving pistons, something has to move. So how on earth could a solid block of metal and wire possibly produce a current? Well, according to the inventors, the answer is something called the Motionless Electromagnetic Generator, or MEG for short. And get this, it's not just an idea. It's an officially patented device from back in 2002. It uses this really clever combination of a permanent magnet, a special core, and a few coils of wire. The secret, they say, isn't about creating energy out of thin air. It's about redirecting it. So how in the world does it work? Well, the most important thing to get is that the MEG doesn't break any laws of physics. It's not creating energy from nothing. Instead, the whole idea is to grab and steer the powerful static magnetic field that's already sitting there inside a permanent magnet. You know, a great way to think about this comes from a commenter online. They said to picture the permanent magnet as a flux battery. It's just constantly full of this magnetic potential energy waiting to be used. The MEG's job is simply to tap into that potential and make it do some work for us. And this is where it gets really clever. Take a look. The magnetic core has two different paths. Now, normally the magnet's energy, its flux, just splits evenly and flows down both paths. But if you send a tiny little electrical pulse into a coil on one of those paths, you create a little magnetic roadblock. You're not overpowering the big magnet, not at all. You're just blocking that one path, which forces the entire powerful magnetic flux to suddenly surge down the other path. Okay, so one big surge of magnetic flux is great, but that's not continuous power. To get a steady flow of electricity, you need to keep that change happening over and over. And that, my friends, is where the switching circuit comes into play. It turns that single surge into a non-stop cycle. The whole thing is actually a really elegant cycle. First, a tiny pulse blocks path A. Whoosh! All the magnetic flux rushes down path B, and that surge creates a jolt of current in the output coil there. Then that pulse stops, and a new pulse blocks path B. Whoosh! The flux all goes rushing back down path A, creating a current in its output coil. By just alternating these tiny input pulses back and forth, you generate this series of powerful output pulses, all by just steering the magnet's existing field left and right. Now, this all sounds pretty slick in theory, but it kind of makes you wonder, right? If it's that simple, why didn't someone invent this 100 years ago? Well, the patent itself actually gives us a clue. It all comes down to a huge leap forward in materials science. The key, according to the inventors, is the development of these things called nanocrystalline magnetic alloys. You can think of them as basically super materials. They're engineered at the atomic level, and they're what make this whole flux switching process efficient enough to actually work. And here's why. These special materials let that magnetic field get redirected almost instantly with very, very little energy loss. They cut way down on something called magnetostriction, which is basically the material's physical resistance to having its magnetic field changed. It's like trying to change the direction of a river. A normal material is like a rough, rocky riverbed. It causes a lot of turbulence and wastes energy. But these nanocrystalline materials are like a perfectly smooth channel. The energy just flows and switches direction effortlessly. That super high efficiency is the secret ingredient. And it's that incredible efficiency that leads us to the most mind-blowing and, let's be honest, the most controversial claim that's made about the MEG. The patent actually reports experimental results showing a coefficient of performance, or COP, of over 3.0. So what does that mean? It means the device was apparently measured producing over 3 times more energy than it took to run that little switching circuit. A COP that's greater than 1 is what people in this field call overunity. It suggests that the device could not only power something else, but it could also power itself from its own output, creating a self-running generator. Now, this isn't a perpetual motion machine. The idea is that it's drawing its extra energy from the permanent magnet, very, very slowly draining its magnetic field over time, kind of like a battery that lasts for years. So this is it. This is the million-dollar question. The theory is fascinating, the patent is totally real, but has anyone actually built one of these that works and can power itself?
When you look around, you find a lot of skepticism. Even dedicated enthusiasts and experimenters who've tried to build one seem to hit a wall. This one commenter, who actually claimed to get some promising results, had to admit that the final critical step, getting the device to power its own circuit, just hasn't happened.
And, this really gets to the heart of the argument from the skeptics. It's been over 20 years since this patent was granted. If this technology actually works the way it claims, where are the products? Where are the independent labs that have successfully replicated it? That silence is what makes so many people really doubt the whole thing. So in the end, we're left with this fascinating puzzle. Is the motionless electromagnetic generator a blueprint for a totally revolutionary energy source? One that's just waiting on the right materials? Or is it just a brilliant concept that, for whatever reason, remains a tantalizing but unproven theory? That is the question that continues to intrigue and challenge inventors and engineers to this day.